Good day, this is the Professor, CBMD PhD, and today's Thursday, June 1st, 2023. It is 5:07 and 10 seconds, AM Eastern Daylight Time, and today's research, Neutron Holograms. So let's jump to it here. Move over lasers. Scientists can now create holograms from neutrons too. Date October 20th, 2016. Source: National Institute of Standards and Technology. As for the first time, a team of scientists have used neutron beams to create holograms of large solid objects, revealing details about their interiors in ways that ordinary laser light-based visual holograms cannot. Holograms flash images that change depending on the viewer's perspective, giving the sense that they are three-dimensional objects owe their striking capability to what's called an interference pattern. All matter such as neutrons and photons of light has the ability to act like ripping waves with peaks and valleys. Like a water wave hitting a gap between the two rocks, a wave can split up and then recombine to create information-rich interference patterns. An optical hologram is made by shining a laser at an object instead of merely photographing the light reflected from the object. A hologram is formed by recording how the reflected laser light waves interfere with each other. The resulting patterns based on the waves, phase differences, or relative positions of their peaks and valleys contain far more information about an object's appearance than a simple photo does, though they don't generally tell us much about its hidden interior. Hidden interiors, however, are just what neutron scientists explore. Neutrons are great at penetrating metals and many other solid things, making neutron beams useful for scientists who create a new substance and want to investigate its properties. Although neutrons have limitations too, they aren't very good for creating visual images. Neutron experiment data is usually expressed as graphs that would look at home in a high school algebra textbook. And this data typically tells them about how a substance is made on average. Fine if they want to know broadly about an object built from a bunch of repeating structures, like a crystal, but not so good if they want to know the details about one specific bit of it. The scientific research involved passing neutrons through a cylinder of aluminium that had tiny spiral staircases carved into one of its circular faces. The cylinder's shape imparted a twist to the neutron beam, but the team also noticed that the beam's individual neutrons changed phase depending on what section of the cylinder they passed through. The thicker the section, the greater the phase shift. Eventually they realized this was essentially the information they needed to create holograms of objects in Earth. The discovery won't change anything about interstellar chess games, but it adds to the palette of techniques scientists have to explore solid materials. The team has shown that all it takes is a beam of neutrons and an interferometer, a detector that measures interference patterns, to create direct visual representations of an object that reveal details about specific points within it. Other techniques measure small features as well, only they are limited to measuring surface properties. This might be a more prudent technique for measuring small, 10-micron size structures and buried interfaces inside the bulk of the material. And this is the Professor of Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.